All right, good morning. I'm Beetle, also known as Don Bailey. I'm a principal security geek on the AWS security team. My day job is protecting AWS customers, their data, and AWS itself.
And I'm Brian Wagner. I am a security consultant for AWS Professional Services, and my day-to-day is helping customers sort of meet or exceed security expectations when using AWS Cloud.
So thanks for joining us today as part of the all-day security track. This is SID302, Force Multiply Your Security Team with Automation and Alexa. So let's go over what we're going to be talking about today. This talk actually builds on a number of previous talks that we've given, which identify and respond to security events within AWS environments. We also use a bit of automation to wrangle all of that. We're going to spend some time discussing our philosophy for automating security tasks. And we will also provide a guide for picking which tasks to automate. Now we're going to discuss some security task automation examples, things that come from a notional security team and the different roles that exist within that team. And we will point out additional resources that will help you make our ideas your reality. And naturally, we're going to have some demos. So why don't we go ahead and just get started with this?
Sure. Alexa, launch Cloud Security Sidekick.
Welcome to your Cloud Security Sidekick. What can I do for you?
Run inspector on all instances for 5 minutes.
Using which rules package?
Common vulnerabilities.
You want me to run inspector on all instances for 5 minutes using the common vulnerabilities rule set, correct?
Yes.
Okay, it's running now. You will be notified when it is complete.
Yeah! Demo 1 is down.
Check.
So this shocked cat photo was a hit last year. It's a hit this year too, and we're big on slide reuse as well.
And cats, we're also big on cats.
Demo reuse too. So now you have a taste of what we're actually going to be talking about today. And again, we'll get to more groovy demos. It's important to understand the journey that we've actually had getting here. I mentioned that this talk is an iteration of previous talks that we've had, and that demo that you saw was from last year's presentation where we talked about automating security event response. And so we finished up with showing an example of how Alexa could be used to launch Inspector for the purposes of scanning for vulnerabilities within an AWS environment. The other talks that we've given, and that we'll casually mention today, have a lot of prerequisites, a lot of concepts that we've introduced before. If you have not become familiar with those or didn't see those talks, don't worry. The YouTube DeLorean is still available to you. You can go back in time, catch up on these. In 2014, we did incident response as well as intrusion detection in the cloud. Wrangling security events in the cloud was in 2015, then automating security events in the cloud. Again, if you missed any of those, don't worry, go back and pick them up on YouTube. And if we don't mess up too much today, this one might be on YouTube as well. So raise your hand if you have an Amazon Echo device.
Yes. Applies.
Raise your other hand if you find Alexa to be helpful.
It's good.
Okay,
Majority.
at least I'm on the Alexa.
Yeah, I'm on both, yeah.
Yes, there we go, yeah. So geeking with Alexa to get security stuff done. And it's a little bit of a science fiction sort of thing, but we're like, why not? Let's just go ahead and do it. The interface for interacting with Alexa is very familiar, right? Nowadays, we're all comfortable with interacting with Alexa, and she's helpful. She's helpful to me, at least, whether it's quick information retrieval or getting some home automation stuff done. And she's consistent, right? For the purposes of driving a workflow that has relatively deterministic activities, right, we can repeat these things over and over, and that's good for some of the process that we're going to introduce today. And whether or not you actually use Alexa becomes a forcing function of sorts when you start thinking of security tasks. So in other words, if I look at a security-related task and I can't figure out a way to actually automate that or use Alexa to help me automate that, then I need to pause and honestly ask myself, is there something, what is it about this task that makes it not something that I can automate, right? What is it that I can't figure out how to automate in this particular case? Is that an indicator for a task that's not particularly scalable? And maybe that's okay for right now, but 100, 1,000, a million customers later, am I going to be wanting to do this thing manually anymore, right? So Alexa just becomes a forcing function for making the decision about whether or not you're going to automate something. If I can't get it done with Alexa, maybe it's something that I need to change in terms of a process. It's also good to have goals, to think about what the security team can accomplish if they're empowered to sort of innovate here. And it starts opening up your eyes to the realm of what's actually possible. And right now, you might not be in a work environment that allows you to willy-nilly hand out echo dots and have the security team start geeking out and automating a bunch of security tasks, but maybe you will. And just like at the movies, for this particular presentation, we'd like you to suspend your disbelief as we go through a number of these types of activities.
So automation, the automation Beetle's been talking about, it should really come from the ground up, right? This is not something you can sort of buy or download. So what I mean is, if you're thinking, if you're going to take this seriously and actually take an Echo device and go start building an Alexa skill around security automation, hopefully you've automated a bunch of other things way before that. Like if you're still, sharing root credentials or something, you shouldn't be putting Alexa over top of your security domain. So, but this sort of operation or this sort of maturity it actually does exist. We do have customers that could theoretically, they're at such a sort of an automation and security maturity level that they could theoretically start automating security operations with Alexa today. In terms of, sort of me as a consultant and AWS in general, we really like to advocate, you build it, you run it, or DevOps. Not everyone's favorite term, but it is, a term that we've all become familiar with. So from a security perspective, you build it, you run it, and you secure it, right? So instead of this show and tell model where you build something and then you say, hey, security, I need you to review this, and it's due tomorrow. So, security has to do all the testing. Like that's what I call show and tell. So the idea of DevSecOps is embedding security requirements early on, right, in the design phase, in the architecture phase, and it permeates the entire life cycle of software development, and that's especially helpful as we help customers that are interested in migrating towards, a microservices style where we have not just one application, but we have dozens or hundreds or even thousands of tiny little applications. So if you want to know more about DevSecOps, Beetle just cheated you out of that, but SID302 later this afternoon is really a customer that's talking about DevSecOps in reality, in practice today, and how they're doing it.
So even if we're employing DevSecOps, we have security that actually permeates our dev environment. Our developers are good owners of security. They're good practitioners. For larger organizations, or as you grow, you end up having a more intentional aspect or thought process with regards to security in the business, and you have a bunch of teams that start getting divvied up along those lines of business when it comes to security. And so our notional security team, if we start thinking about folks that have roles within security, we think about the folks at the beginning of a software development life cycle that are helping our developers, our application security team, geeking out with those devs when they're coming up with their ideas, making sure that instead of saying no, they're asking how, right? How can we enable the business? Helping them get across the finish line in terms of release, ensuring that that's consistent with how we want to protect customers and their data. Our compliance folks, right? We want to collect all the pieces of flair with regards to compliance, enabling compliance for the purposes of more customers that may want to run on our platform is very important for us, but also demonstrating how we maintain that compliance in terms of controls, monitoring those controls, whether we're scanning for vulnerabilities, whether we're checking configurations. Security engineering, people that are internal to the organization that are continuously raising the bar with how we actually practice security, whether it's with our systems, whether it's throughout our infrastructure, our protective mechanisms that we have in place, and then security operations folks who actually look at what's coming down the pipeline in terms of events, reacting to that, managing that in terms of risk, determining whether or not they need to perform remediation actions. And then if they find something that's interesting, or we have some guys that are out there analyzing the weather on the internet and helping us understand what risks are actually applicable to our environments, we have threat intelligence folks. And so these are a number of different natural lines of the business that start to split off and diverge and that you may apply actual dedicated staff to. For smaller shops, a lot of the above is consolidated, where AppSec folks are also the compliance folks, right? Or the security operations folks are also doing security engineering as well as threat intelligence. But all of this work still needs to get done. Who here has all of the above in terms of all of these lines of business, right? And who here is responsible for all of the above? Like, you're that guy,
Nice.
right? The security army of one. Yes, awesome. We salute you.
We do.
Yes, that's awesome. So I venture to say whether or not you're the one guy that's handling all of the above, or whether you're part of one of those teams that's making the security mission a success, there's probably something within the realm of what you're doing that makes you go ugh, right? This, whether it's manual stuff or repetitive stuff or time-consuming stuff or the soul-crushing stuff, right? Generally, we would prefer the work that makes us go as opposed to the work that makes us go ugh, right? And as passionate as we are, right, about the security field, right, and doing the security things, there is some work that exists that we would, like to do less of, or we would love it more if we didn't have to wrestle with it or struggle with it as much, right?
And the struggle is definitely real.
Absolutely. So my boss talks about how our security team, the culture that we have, is one that does not say no. Instead, we are biased towards saying how, right? When we are talking with developers, we're asking, how can we make this idea a reality? How can we get it across the finish line? How can we enable the business? So it's interesting that security geeks, and I'm sure there's a few of you in here who have at least embraced the culture of not saying no, and now you're saying how to your developers. At the same time, you're super hard on yourselves, right? You say no to yourself so many other times, or to your teammates with regards to the process that they follow, and that they must adhere to this. This is the process. This is the tool, right? Here are the alerts. Classify the alerts. Triage the alerts. Go make the donuts, right? Rather than actually empower your security team to start innovating and thinking about how to change their line of business, right? Their ideas and making those a reality. So it's a good idea to think about why we should enable them or why we should empower them to do this, right? They have the deepest understanding, our security staff, our teammates have the deepest understanding of the business, right? So let's use them to figure out how we're going to solve our own problems, right? Also, in many cases, when you give them the opportunity to solve these problems with automation, or even to do something as interesting as using Alexa for it, self-preservation kicks in, right? The destiny of the team is clearly in their hands, right? And there are real build versus buy economics at play here, right? Because you seriously might not be able to afford a particular market product, or maybe even the time it takes to customize that particular product for your environment, right? So homegrown might actually make some sense for you. So going down this path is very intentional, right? It's taking control. It's not hope. It's not holding out for a hero, because you end up being the hero yourself that you deserve and need. So to avoid essentially burnout, and we do think that it's real within this particular industry, think about how you can enable your team to do these types of things with Alexa, and that's what we're trying to introduce to you.
So I heard soul-crushing, burnout, and making donuts instead of eating them. So while that sounds incredibly depressing, thank you, Beetle, AWS is a ray of sunshine into that darkness, right, that Beetle just currently described. So if those things that make you go, ugh, land within the AWS domain, the good news is that AWS is an enabler for automation, for automating the ugh away from you, right? So as we should all probably know, everything on AWS is an API call, right? So it gives you a ton of information. You can list resources or describe a resource, and you get back, JSON, you get some data, and you can take that and you can search through that with whatever your favorite search tool is, or programmatically kind of scour through and get the information that you want. Or you can, you could automate that and wrap it up into something handy and put Alexa in front of it. And that's kind of what we're talking about today. So over the years, if you guys were around or using AWS right when Lambda came out, I mean, Lambda really changed a lot of things about how we operate in AWS and think about, sort of event-driven compute.
Who uses Lambda right now?
Yeah, it's a staple, right? But we've come a long way from this mechanism where you have to constantly ask or poll for something being done, right? When you call an API call, that invokes something that happens after that. And that thing might happen within, a sub-second operation, or it could take, in the case of our inspector demo, 5 minutes. But it used to be that you have to ask, is it done, is it done? But now we have very much more this sort of push framework that says when it's done, we can do a thing. And then you can do whatever you like with that. You can take it the extra mile, and you can write a function for it. Or if there's a product out there, we have amazing technology partners that allow you to consume some of this data and do a lot of cool stuff for you. So at high level, you've got people or stuff or things or whatever interacting with API endpoints, right? So AWS is we're capturing this activity for you, delivering it for offline review in terms of CloudTrail, or you can subscribe to CloudWatch events for interesting stuff happening within that environment. You can store it offline, analyze it at your leisure, or if you need it for compliance purposes. There's a lot of stuff you can do with that sort of that data at rest. Or we can start creating functions and things to react to cool stuff or interesting stuff happening within that data stream. And the output of those functions don't have to only be notifications, right? They can be downstream. They can trigger Lambda, generally speaking, but a lot of other things as well to trigger some downstream actions. And you can take real action with carefully scoped roles and credentials, of course, that enforce security policies at scale around the clock.
So we talked about this last year at reInvent, the journey of automating your security event wrangling in AWS, going from idea to code to execution. And we also presented a number of questions that you could ask yourself that would help with decision support in terms of like, how am I going to automate this? What mechanisms am I going to use? What's the reality of this going to be when I get to the finish line in terms of automating this workflow? And so the first thing that you have to figure out is, can I describe what it is that I want in very simple terms, right? Can I get that security objective in simple terms so that I can start breaking that down and understanding what components are actually going to be used to deliver this as reality? Is what I'm trying to achieve configuration related or behavior related? Because based on that answer, the answer to that question, we will know which services we're going to consume and or their logs for the purposes of making more decisions. So if it's AWS config and using the output from a run of that or any alerts from that, or for configuration reasons, or if it's behavior related where we're watching CloudWatch events, then we need to make that decision, right, in terms of where the data is going to be. And the data is important. That's what we're pivoting off of, right? Whether it is an analysis of data or whether it's a particular event, understanding what it is we're going to process. You also have to have the right ownership of that data. In a previous talk, we've introduced the idea of a security role or an audit role, somebody that has the visibility into the account that has the outputs that we would like to consume and then make decisions off of, right? So you have to enable that role to have that visibility. You have to have permission to read the data that you would like to actually act upon. And what mechanisms are going to support doing the above, right? Particular to our performance objectives. So if I need to have something done within a day, right, then having a grab of some data that sits within an S3 bucket on an hourly, every 12-hour period, maybe that's fine, right? If it's something that I need to know every 5 minutes, maybe I need something that's streaming data, right? So I'm looking at actual events as they're occurring. Maybe I'm feeding them into a Kinesis stream, right? And those are two completely separate mechanisms in terms of where the data is going to reside, how I'm going to consume it. And of course, once we figure out what it is that we're going to do and how we're going to do it, we have to find somebody to actually implement that for us, right? So we need familiarity in the platform, somebody that understands maybe how to use Lambda and consume events and create another workflow. Or maybe we need to look for partner solutions that will help us there. So let's go back to where we were at the very beginning where we ran the demo and we had the compliance team, in this case, trying to get something done. And for them, it was very simple, right? We'll express their security objective in words. I want to identify any instances running vulnerable software. And so under the hood, what did that end up looking like?
Right, so if we're recapping that first demo. So if you remember, what I said to Alexa was run inspector on all instances for 5 minutes. And then she came back and asked me using what rule set. And I said common vulnerabilities. So it's really 3 primary inputs. So, well, 4 if you include inspector. So I said inspector so she knows how to route it. 5 minutes, so we needed a duration. How long to run inspector for? What instances to run it on. In this case, it would be all, but that is indeed an input. And also, what rule set. She didn't get that third one. I kind of did that on purpose. I could have said all 3 in one, or I could have used none of them. But my point is, from left to right as you're reading on the screen, or top left rather. So first, Alexa is collecting 3 inputs. Once we've collected those 3 inputs, she's now ready to take those inputs and go on, move downstream. Now, we're obviously big fans of Lambda here, us and you guys included. So if you've ever written an Alexa skill, generally it's a Lambda function, right? So Alexa is a Lambda function, and we also need to invoke another Lambda function to do what we want to do, which in this case is run inspector. Now, if you've ever invoked Lambda from Lambda, the best practice, if you didn't know, now you know, is SNS notification. So that's the best practice to invoke one Lambda from another, is to send SNS across to invoke. So what we've done here is we've collected our 3 inputs, put them into an SNS message, and sent it off to my next Lambda function, which then calls inspector. So inspector needs those 3 pieces of information: what instances, the duration, and what rule set. Now, the cool thing about that function is that it doesn't have to be contextually aware that Alexa's calling it. It just needs those 3 inputs. So it's flexible enough that you could use that same function in some other part of your automation workflow. So this whole idea that you have to sort of shim it into Alexa isn't true. So Alexa's just gathering those inputs for you. So the 3 inputs, 2 of them should be pretty obvious: the rule set and the duration. But when I used all, right, all instances, the way inspector works, if you think about inspector, it is a per instance operation. If I'm asking to run inspector on some instances, it's got to know where to go, which ones. In this case, I said all, so that's pretty easy. In our very simple 3-tier environment, you can see up here. There's just load balancer, web tier, app tier, really simple, data tier as well. And you see those little tags. That was my artwork, not a Photoshop guy, security guy. So P is short for purpose. I just didn't want to consume the whole slide. But basically, I've identified through my automation that we've sort of preempted up to this point, that my environment is tagged accordingly. So if I said all, we don't really care too much about it. We're just going to grab all of our instances in scope. But if I said tag my web instances, well, that's how inspector knows what to do. It needs that input to say, what am I supposed to do, or where am I supposed to do it? But of course, those inputs, you have to translate that stuff in the Alexa skill to finally get downstream to the inspector function.
And of course, that's neat, right? The idea that we're using Alexa to consume the voice commands and then start triggering another set of Lambda functions in a workflow that goes. We could have done that, though, with a script, right? Could have done it with like a push button. And actually, there's a number of things that we could create buttons for, where you just push the button and it goes and does something within the environment. We've actually given presentations on push button security tasks, right? Like run a penetration test with the push of a button. But there may be some added complexity to a workflow where you actually need a bit of a guide, somebody to help you along, prompt you as to what to do next. And so Alexa is fantastic for that. You might have an automated process for a number of different things that you're fairly confident in, but you want an escape valve at the end, where you want a human in the decision-making process, somebody in the loop to decide go or no go at this point right now if we're moving forward with this particular function. And so that's a good use of Alexa as well. And if you're using a fully automated process that does a lot of things behind the scenes on a regular, recurring basis, but now you want to run it ad hoc. Just spur of the moment, I'm in the hallway, I decide I want to go and run that particular scan, I can go and do that ad hoc. Of course, I could do that by typing in a command and hitting enter, but it's a lot easier to just talk to essentially an echo dot and ask Alexa to do it for me. Those are obvious benefits. There are some benefits that are not as obvious, most notably staff flexibility. So not having a single point of failure within your shop, right? Automating with Alexa makes a task sort of a democratic sort of thing, right? In other words, it's no longer a specialist task, it's something that somebody else within the shop can also do. It increases the availability of that and ensures that someone can carry on with the actual workflow. And when you expose these well-defined Alexa-driven workflows to, say, new members of the team, it becomes a training function as well. So you can actually use Alexa-driven workflows as a means of training new members of the team to understand what are all the things that we do, right? How do I do those things? Maybe there will be specialized tools and workflows that they end up learning later on, but to begin with, understanding just the basics of who's interacting with whom, where the workflows are going, Alexa ends up being a great forcing function for that. And it's not to say that automation here is either or. Like, you don't need to automate all the things. There can still be some things that you do automate. You don't have to use Alexa, but some aspects of what you're doing, I can assure you, would benefit from having an actual Alexa-driven workflow for that. So here's a quick glance at some suggestions of things that you should probably be thinking about in terms of at least automating, right? Getting out of the business of a human doing this on a regular basis, understanding that this can be done for you, right? In the realm of compliance, folks that are performing audits, right? Performing inventories, scanning instances, that sort of thing, fine. You can regularly schedule those, or you could have those ad hoc driven with an Alexa-driven workflow. The engineering folks, if they're patching things, if they're refreshing an environment, anything that you've ironed out in that particular realm and that you know that you've got down to a science, let's go ahead and get it automated, make it push button, and then see how far you can drive it in terms of a voice-driven workflow. Operations guys, right? There's all sorts of things that are thrown at the operations guys. However, there's a lot of standard response that you actually perform within security operations, whether it's isolating a resource, tagging a resource, applying standard ACLs to something, applying a more restrictive resource policy to a set of credentials. These are all things that you can start thinking about automating. And then for pre-built analysis workflows, particularly within the threat intelligence world, whether it's forensics, log dives for a particular entity, right, and getting a report sent afterwards of that particular entity in those logs. These are things that you could potentially automate. And then there's a number of standard reports where you might have these reports generated regularly, but now you want one off the cuff, right? Now you want a refresh or a latest version of that since the last time you ran it. These are all great things within the security org that we can start automating. So we've talked about essentially the compliance guys performing a scan, finding some vulnerabilities within instances, but when they do that, you know, we'd like them to have their workflow, not necessarily them, automatically notify somebody else to actually do something. So how are we going to pivot from that, right?
Yes, absolutely. So first we kind of want to know what's going on,
Yeah.
I imagine. So Alexa, ask Cloud Security Sidekick for the results of my last inspector assessment.
Inspector was last run 26 minutes ago for the common vulnerabilities rule set on all instances. There were 8 high severity out of a total of 26 findings.
Okay. So, great. Now we know that we have some vulnerabilities. That's pretty helpful. But now what, right? What do we do with vulnerabilities? We patch them, naturally. So patching is a very similar operation from an infrastructure perspective to running inspector in the first place, as it is in a per instance operation, right? You can't patch at a top level. It has to go per instance. So we asked to run inspector on all, but now we have a subset of instances potentially with vulnerabilities, or in this case, vulnerabilities of high severity. So how do we know? How do we know what we should be patching, right? So how do we find out? We could, of course, based on the inspector results, go into the inspector console and look it up and pull up the IDs and then, you know, jot those IDs down, and then what do we log into each ID with SSH or whatever, and, you know, one by one. I mean, yeah, you could, but what if there's 10 of those? What if there's 100 or 1,000 or 10,000, right? How do you patch 10,000 instances? So obviously this can become very unmanageable very, very quickly. So anyway, with Inspector, when an assessment completes, you actually have the option of sending the findings, the results of the findings, in a notification via SNS. So I've configured my Inspector environment to do exactly that. So when it's done, it emits this event to SNS, and it includes the findings, you know, as in all the instances affected, what the severities were, and all of that. It can send all that through this SNS pipeline with the data in tow. So what we're going to do is hook it up to Lambda, of course. So Lambda is going to know, because I told it to, what to do with this information. So the concept I just told you about taking every single instance ID and doing X to it, we're going to kind of enrich the data a little bit with the use of tagging. We're going to use tagging very heavily here. So my Lambda function, once it figures out that there are some findings, it's going to go through and tag with 2 things on the instances in scope. One is vulnerable equals true. So whether or not it's, you know, we'll deal with the severity in just a minute, but it also tags the severity. So is it high, medium, low, or informational? So Y2 we'll get into in just a second. So now that we know that there are tags, again, we still haven't done anything with it. We go back to our dear old friend, CloudWatch events, to listen for a rule, because tagging, like anything else in AWS, is indeed an API call. API calls are logged in CloudTrail, and then CloudTrail can be picked up in CloudWatch events, and then, in this case, create tag. That is the actual event that we're looking for, anytime a tag is created. Now, think about that. Anytime a tag is created. On EC2, you can have up to 50 tags on a resource. In our environment, which is already heavily automated, relies on tagging constantly. So that's actually could be a pretty noisy operation. So because that rule does fire every time a tag is created, whether it's innocuous or not. So one way to squelch the noise, that's kind of dealing with your signal to noise ratio, is to hook it up to a Lambda function, of course, that can investigate the nature of the tags and decide what to do. And last year we called those things responders, or Lambda responders. So in this case, it's going to send an email. Pretty simple. It's a notification. We just want to draw attention that there is one or more instances that are vulnerable, right? So there's just an example email there. Now, keep in mind, this isn't the only option. You don't have to stop there. So really, in terms of CloudWatch rules, you can actually hook up multiple, what we call them, targets, right? Multiple notifications, or notifications and, open a ticket and do X and do Y. So there's really other options. You can go right to Firehose, or dump something to S3, or call a Lambda function, my personal favorite. But yeah, the point is, you don't have to decide what to do with one thing. You can have this one event that is useful to maybe multiple teams, perhaps, that all have their own sort of event based on some interesting information. So now maybe it's time to do something about the vulnerable instances.
Right. So the compliance folks have found some instances that are vulnerable, and the security engineering folks, whether they were automatically notified, they got this email notification, or the compliance folks walked across the hall and actually told them the old-fashioned way, they have a goal now, right? They've got work to do. And we express that work simply: I want to patch any instances running vulnerable software. So let's do it.
Yes, let's. Alexa, tell Cloud Security Sidekick to patch my vulnerable instances.
For which level of severity?
High.
Okay, I'm patching vulnerable instances of high severity.
Great. So of course we could patch the low severity vulnerabilities later, or we could patch the high severity vulnerabilities, the mediums, the lows, all the vulnerabilities all at the same time, right? Let's get it done.
Sure, we could do that. So Alexa, tell Cloud Security Sidekick to patch my vulnerable instances.
For which level of severity?
Patch all the things.
Okay, I'm patching all the things.
Thank you so much. So let's just go on a little bit of a tangent for a moment, right? So now we're talking about patching. First, we started with Inspector. Inspector is a service. Service, it does a thing. So patching is, it's OS maintenance, and traditionally, part of the Amazon, the AWS shared responsibility model, in terms of EC2 specifically, you guys, the customer, is responsible for that operating system, right? So we're kind of hands off on that. But like a lot of things on AWS, we think we do a pretty good job of giving tools to customers to make that part of the responsibility model easier to manage. So we've, through the talks over the years, we've got Lambda, we've got CloudWatch, we've got CloudWatch events and responders and all that stuff. So I'd like to introduce a new tool to the workflow, which is Ec2 Systems Manager. So if you're not familiar with this service, it is a part of our management service offerings that help you automatically do things at the OS level, like collect software inventory, apply OS patches, create system images, and even do sort of OS level configurations across Linux and Windows environments. It's basically an OS level, like Swiss Army knife sort of thing. And in a lot of cases, it's a drop-in replacement for an interactive session such as SSH or remote desktop if you're using Windows. And of course, as it is indeed an AWS service, it is API driven. Therefore, we can automate it with Alexa or anything else if you like. So in terms of what actually is going on here, how are we going to use this thing? It should be relatively familiar architecturally speaking. That's kind of the point. But of course, instead of running Inspector, we're going to run I don't know if it's called a subservice or whatever, a feature of Systems Manager that is called Patch Manager. So Patch Manager does exactly what it sounds like, or you would hope. It has basically two modes of operation. One is do a baseline. It's just a sort of a recon, and it'll report back and say, this subset of instances is out of date from patching. We've found all these relevant patches to your operating systems in scope, and you want to bring that from like red to green, basically. And of course, the other one is go do something about it. If it's out of date, go ahead and patch it. So Patch Manager and Ec2 Systems Manager in general relies on the same identification mechanism as Inspector, which that is tag-based. You can define individual instance IDs, but it's a lot easier in dynamic environments to say, I want to tag, run these patches on this group of things. So if you kind of rewind to the last when we talked about patching high severity versus all versus medium or whatever, that's what we're using here. We're using vulnerable is true and severity equals whatever level. So that's how we're going to use Patch Manager in this case to decide or to tell it which instances that are in scope for this particular discrete operation. So and patching does take a little bit of time though. So.
That's true. So we'll let that get. That's another workflow.
It is.
Right. So and that's at the end of the day, when guys are finding things that are vulnerable and other parts of the team are patching things that are vulnerable, this is the eat your vegetables security work that we do, right? All the proactive work that we're supposed to be doing in a healthy security environment, all of our work is not proactive. Some of our work is reactive. So in the case of the security operations team finding out from whether it's another notification, maybe it's an email that has identified an instance that's misbehaving, who knows?
Bad instance.
Yeah, yesterday it was getting a lot of web requests. Today it's making a lot of web requests. We don't like that. If we want to do something about it, we have to have effective mechanisms to do that. And within security operations, expressing that as a simple operation, something I would like to accomplish, I want to tag and isolate an abnormally acting instance.
Let's do it.
Yeah.
Alexa, tell Cloud Security Sidekick to tag Wolfman.
What do you want to tag it as?
Suspicious.
Under what suspicion? Billing, networking, compute, application, or other?
Networking.
Okay, I've tagged instance Wolfman as suspicious for networking activity.
Okay, so we've now gotten the tagging portion of this done, right? Where we're identifying an instance for maybe another workflow. In fact, if we tag it as suspicious, maybe that lets somebody else know. We can actually drive an asynchronous set of workflow events to occur while we now get about the business of remediation, right? In the case of a misbehaving instance, just saying it's bad isn't enough, right? That's not the warm fuzzy that we want. We need to actually isolate it, so let's go ahead and make sure we isolate it too.
Alexa, tell Cloud Security Sidekick to isolate Wolfman.
Okay, I'm isolating Wolfman now.
Cool. So let's we'll kind of break that down. That was in two pieces, right? So first we want to tag stuff. And it's pretty simple. I just asked Alexa, or my Cloud Security Sidekick in this case, to have an instance tagged with a certain key. Key equals true. So if you've worked with tagging, tagging is actually two. There's a key and there's a value. And several times now, I've actually only given one of those things. I've basically programmed Alexa so when we're listening for something that we need to tag for, if I don't give a value, it assumes the value to be true. So if I say suspicious, we're going to see a tag that's going to say, it's not really represented there, but suspicious equals true. Kind of like the vulnerable equals true thing. It's the same idea. So, and of course I called it by name, and I named my instances after Top Gun call signs. I thought that would be fun. Yes. But yeah, she also knows that because I asked to name it suspicious to ask me a follow-up question. What are you tagging it as suspicious for? So very similar to the severity or in the vulnerability case, we've enriched the data. We're adding another tag to kind of give some interesting information. So
we could call an instance weird.
We could call it weird, but we could also call it, if the instance was named Maverick, we can call it dangerous. That's right. He is dangerous, if you remember the movie. Anyway, that was a bad joke. So, yeah, you could call it anything you want, right? Or you can call it, X equals Y, whatever. But the point is to enrich the data for that downstream work or person or whatever the outcome is in your automation workflow to understand why it's suspicious or what did you think happened to it, right? So now we've applied some tags just like before, And CloudWatch events is already listening. We had that create tag, that rule that we're matching, so this thing is firing all the time. So we'll need an appropriate responder to sort of deal with what suspicious equals true really means.
Right, and so if we have something that's listening for that CloudWatch event, parsing effectively the tags that it sees suspicious. Whenever it sees suspicious, maybe it goes over to the Slack channel where the threat intel team's living, and to tell them, hey, those guys over in operations, they just tagged something as suspicious. You might have some work to do, right?
Yep.
We'll get to what they're doing in just a bit, but we got to get back to the remediation part, when we actually isolate the instance, what's going on.
Right, so from isolation perspective, a pretty direct operation. So in this case, we would have some scripting in Lambda behind the scenes that is going to really do primarily a couple of things, like 3 things in context here. So one is to scope down the role, the instance on the instance profile, the EC2 instance. So let's say, if that instance is indeed suspicious, you don't want someone having access to, if that thing can write to your database or write to S3 or something, you probably want to revoke that access just in case. You also have the security group around it from a networking perspective. You want to lock that down to only accept connections from maybe your forensics workflow or whatever. And then sort of operationally speaking in terms of the application, this application is load balanced, so we want to take it out of service. I don't want the load balancer to give my suspicious instance more connections and more opportunities to be weird. So, and of course, if the load balancer and everything is in a healthy, auto-scaled, highly available environment, it should have no impact.
Right, pulling an instance is completely
fine.
Yeah,
it should be no problem. So as a result, we've now got this running instance more or less cut off from the world, right, so to speak. But it certainly has our attention, so maybe we can learn more about it.
Right, so the threat intelligence team, they get the heads up notification in a Slack channel, and it says, hey, you've got some work to do. Their goal now, simply expressed, right, is I want to run forensics on an instance previously tagged as suspicious. So let's do that.
Let's do that. So Alexa, tell Cloud Security Sidekick to run forensics.
Which instance do you want to run forensics on?
Wolfman.
What type of forensics do you want to run? Networking, disk, memory, or other?
Networking.
Okay, I'll perform networking forensics on Wolfman. You will be notified when it is complete.
Groovy. So I did a pretty simple operation. I just asked Alexa to run a forensics assessment after the instance was isolated, right? So now we have this living artifact of the possibility of finding out what, if anything, went bump that drew our attention to it, right? Raised suspicion. So, we don't have a forensics as a service, right? We have inspector, we have patch manager, but we don't have like a forensics as a service. So what we do have in terms of Ec2 Systems Manager, if you remember that slide with the green things all over it, there's a lot more than just patch manager. And one of those things is a subservice called run command. So what run command can do for you is basically, in sequence, make arbitrary calls to your instances to run, again, anything you want. Or in this case, we might be running Margarita shotgun from threat response for memory capture, right? We can invoke that, and that's not a service from us, but you can still invoke that on one or as many instances as you like. So now let's find out what we found out from the networking forensics run. So Alexa, tell Cloud Security Sidekick, no, hold on a second, I messed that invocation up. Let's try again. Alexa, ask Cloud Security Sidekick for my last forensics run.
The last forensics assessment was for networking a minute ago on instance Wolfman, and there were 2 findings. According to CloudTrail, Authorized security group Ingress was called from a source IP address outside of known address space. According to VPC flow logs, port 22 access was attempted from a source IP address outside of known address space. I've sent you a detailed report via email.
So what did we do there? Like, what did I do there, I guess? We didn't do it, I did it. Well, we did it.
She did it.
You guys did it. You can do it. Anyway, but what did we do? What was that particular forensics run? I thought here for this demo it would be interesting to leverage the metadata from the EC2 instance itself, from Wolfman. So Wolfman, of course, is a tag, name equals Wolfman. But I wanted to pull the instance ID and look through CloudTrail to see if anything in that, with that instance ID, I can filter down by that resource and see if there's anything weird that might have changed its access posture. And indeed, Authorized security group Ingress was impacted on that particular instance from a network outside of our, our known range.
Right, so somebody outside the company is making changes to security groups.
Right, so as a follow-up, we looked through the VPC flow logs for the IP address of that same instance to see if there's anything like weird going on, and maybe it was denied or whatever, but the fact is someone changed the ingress and then started trying to access it, right? So basically, the output of this process did have to be Alexa-friendly, right? It didn't output something in plain English like that. I had to sort of take the interesting parts of that JSON, a very structured output from both of those things, and craft it into sort of a plain English Alexa-friendly response. But I don't think that changes the utility of that operation at all.
No, it's pretty cool. And we've covered a number of different things that we can now do with Alexa within our security team across a number of different business lines. We've covered a bunch of activities here, whether it's launching inspector, patching instances, isolating misbehaving instances, even performing forensic analysis on a misbehaving instance. But we forgot somebody.
We did?
Yeah, we absolutely did.
Oh, your boss.
That's right,
yeah,
my
you
boss.
forgot your boss. Don't tell him.
So we left out the boss. Now, whether you're a one-man security team, right, or you're the security leader of a bunch of teams that are getting all of the above done, right, having awareness of what's actually going on is pretty important. And I know that my boss, AWS CISO Steve Schmidt, he'd appreciate something that's a little bit more convenient for that, right? So if Steve's goal simply expressed, it would probably be something like this. I want to know what my awesome security team has done recently.
Giving yourself a lot of credit, but we can do that. Alexa, ask Cloud Security Sidekick for my flash briefing.
Since your last briefing, the following events have occurred. Compliance used Inspector to identify a total of 26 findings. Security engineering has patched vulnerable instances of high severity. Security engineering has patched vulnerable instances. Security operations tagged one instance as suspicious for networking activity. Security operations isolated one instance. Threat intelligence performed forensics and discovered that a security group was modified from an IP address outside of the corporate network, and that an instance was attempted access from an IP address outside of the corporate network. There are no news reports or security bulletins with CVEs related to your AWS environment.
Cool.
Yes. Yes, but we're not going to show him that demo just yet.
No, not yet.
Okay,
He
good.
won't. Good thing he doesn't know what YouTube is. You'll never find it.
That's right. So what are some other resources for folks that are interested in security automation, right? We've talked about a lot of fun things within this talk. You should also check out these places as well. So Threat Response, for starters, have an open source incident response toolkit for AWS. So visit threatresponse.cloud to check that out. There's a lot of things that you could hook up to an automated workflow that come from those tools, right? In addition, one of our customers, Netflix, they do some fantastic things on the front of security automation. And they've published open source tools as well. So check out their GitHub, look for things like Security Monkey or Scumbler. And then NCC Group has a tool, Scout2, which is great for assessing an AWS environment and looking for risks. And then you could take the output of that and pump that into an automated workflow as well. If you're looking for opportunities to practice these sorts of things, to get more familiarity with responding to events within an AWS environment and developing even automation to deal with those types of events, you should check out one of our security jams. We have a security jam that's going on here at reInvent. Starts tomorrow. Yep. I think we have 1,000 or more people signed up for it at this point. Last year was the first security jam. We had 200 folks, yep. 4 teams of 50, or 50 teams of 4, competing in a defensive capture the flag event, and that was a lot of fun. We've created another iteration of that based on a lot of feedback, and we have new challenges, and some of those challenges have to be responded to at scale, so you have to develop some automation to actually deal with those particular events. So our security jam is a great place to get some more practice. Clearly, there's solutions within the marketplace, security related. A number of those have outputs that you could consume and start pumping into an automated workflow as well. So make sure you visit the marketplace, kick the tires on some products, and see how they integrate into your automated workflows. Some interesting AWS partners who think about security at scale the same way that we do, who can help you automatically identify and manage a number of risks associated with your AWS environment, include folks like AlertLogic, Splunk, Dome9, SkyHigh. check out these folks on the expo floor as well as their products and see how they might help you with your automated workflows. Other talks. So if security automation is your thing, beyond the old stuff that we have in presentations and on YouTube and the things we talked about today, here are some other talks during reInvent that you might be interested in. Particularly using AWS Lambda as a security team, right? That's going to give you a lot more fundamentals in terms of connecting any number of workflows together. It might not be voice-driven, but it's definitely automated. Looking at how Netflix and we have partnered on a number of things to do security at scale, right? So you'll learn effectively how Netflix is doing that, SecOps 2021. Check that one out. Incident response in the cloud, another version of that out and about these days. And if you'd like to learn how the AWS security team thinks about security, automate security, have some insight into our own tools, check out the AWS Philosophy of Security by distinguished engineer Eric Brandwein on our team. And if it's not security related specifically, but it is Alexa related, check out applying Alexa's natural language to your challenges. Hey, don't forget to check out support. If you have any issues or concerns with your AWS environment, hit them up. They are your one-stop shop for anything that you need in terms of addressing any issues. If they don't have the answer or an immediate solution for you, they understand exactly how to get a hold of the internal team to help you with your specific problem. Even if it's security related, they know how to escalate to the AWS security team specifically. And if you want to learn more about the AWS security team, what we do, or to learn about security guides of or in AWS, we have a ton of helpful material, whether it's quick starts, compliance guides, white papers, you name it, we've got it on the website. You can keep up to date with security-related services and features that we're releasing, some of those during reInvent by visiting the AWS security blog. And of course, if you don't find what you're looking for immediately or you just have a random question, you are always welcome to email us on the AWS security team at aws-security@amazon.com. And so, summarizing what we've gone over today, automating security stuff with Alexa is not science fiction, okay? It's real, you can get stuff done, and a lot of those security-related things that you're doing right now are ripe for automation, if not for Alexa. Empower your security geeks. Get them to invent with automation, right? It's rewarding for you as well as for them. So think about what you can do to put more work on their plate, but for the purposes of inventing with automation. Take advantage of a bunch of the previous talks that we've given on this particular topic and the related material. Make sure you check out Partner Solutions and go find some security-related UG and automate it with Alexa today.
Cool.
Thanks, guys.
Thanks, everybody.